Dear students, anything which can be measured is called a quantity. For example, mass, length, time, current, temperature, etc. Quantities are of two types. The quantity whose value remains same with respect to time or with respect to space, that means in any surroundings value remains same, then we can say that the quantity is a constant. And on the other hand, a quantity whose values varies with surrounding or time are called variable. That means the value changes with respect to time, with respect to temperature, with respect to pressure, with respect to weather conditions. These are called variables. Again, variables are of two types: dependent variables, independent variables. Let us consider, if a value of certain quantity y depends on the value of other quantity x, then y is called a function of x. That means the value of y changes with respect to change in x. If value of x changes, then value of y also changes. In that case, we can say that y is a function of x, and mathematically it can be represented as y equal fx. F stands for function, or f represent function of x. Instead of small letter f, we can sometimes write it as capital letter fx, that is function of x. Psi x, phi x, all represent same meaning, that is function of x. Y is a function of x, y is a function of x, y is a function of x. It doesn't matter what symbol we are using here. So we come to know that y is dependent on x, but x is independent of y. So we can say that x is a independent variable. X is a independent variable, but y is a dependent variable. Now, if delta x is a small increase in value of x, that means if value of x changes by delta x, then there is a corresponding change in the value of y. Since y is a function of x, then the corresponding change in y will be delta y. So if delta x be a small change in the value of x and delta y be the corresponding change in y, such that the function can be written as, due to the change in x, y also changes or vary. Therefore, y plus delta y is equal to function of x plus delta x. So delta y and delta x are the increment or decrement. If it is negative, then we call it as decrement. So delta y and delta x is also called the increment in y and increment in x. So the average ratio of increment in y to the increment in x can be written as the differential or derivative of the functions. So delta y by delta x is the average change in the value of the function fx. Let us assume that change in x or increment in x is equal to tends to 0. That means the change in value of x is very small but have positive quantity. So in that case, we can limit the increment ratio or average change by using this expression. So limit delta x tends to 0 to the ratio average change delta y by delta x can be written as limit delta x tends to 0. This is a new function y that due to the change in delta x. So in place of y we are writing here function of x plus delta x minus y, that is function of x divided by change in x. So this can be written as rate of change of function y. This can be written as rate of change of function y with respect to x, or differential coefficient or derivative of function y with respect to x. So if it exist, if it exists, then this is called the rate of change of y with respect to x, or differential coefficient of y with respect to x, or derivative of y with respect to x. So this can be represented by a symbol or denoted by a symbol. It is dy by dx, and read as derivative of y with respect to x, or differential coefficient of y with respect to x. So this is the concept of differentiation or derivative. So dy by dx can be read as differential coefficient of y with respect to x, or derivative of y with respect to x. Thus, differentiation of any constant with respect to x is always zero. Because value of constant do not change with respect to any physical quantity. In differentiation of any function multiplied by a constant, for example, c is a constant and u is a function of x. U is a function of x. In this case also, c is a constant. If we differentiate c constant, we will get 0. So we are writing in this manner: differentiation of u, which is function of x, to the x. So constant multiplied by differentiation of u with respect to x. If the two functions are added or subtracted to each other, then this can be differentiated separately. Differentiation of u with respect to x plus or minus differentiation of v with respect to x. If the two functions are multiplied to each other, then also this can be solved in this manner. First of all, then we will differentiate second function first. Then once differentiation of v, then take out v and now differentiate u with respect to x. Then put the value of function value of v and u, then differentiate, and after that have some numerical examples. First of all, differentiate the following with respect to x. So, what are the questions? 1993. We have to differentiate this number with respect to x. So, write in this manner. Differentiation of 1993 with respect to x. It is a constant number. It doesn't vary with time, x. Therefore, differentiation of this number is 0. Similarly, differentiation of pi with respect to x also give us 0 because it is also a constant. And differentiation of exponential e is also equals to 0 because it is also a function which doesn't vary with x. So any constant or isolated constant are differentiated, then we will get an ultimate answer, that is 0. If we are asked to differentiate a function of x, that is x to the power 3 x cube, then we will use the formula x to the power n is equal to n. Here we have identity. Differentiation of u to the power n is equal to n u n minus 1 differentiation of u with respect to x. We will use this identity or formula. Then differentiation of x cube with respect to x becomes, what is the value of n here? It is 3. So 3x n minus 1 is 3 minus 1 differentiation of x by x. So it gives us value 3x squared differentiation of x with respect to x. That means these are same variables. So once variable are same, then we can write here 1. It is 1. Differentiation of x with respect to x gives us 1. So our answer is 3x squared. That means differentiation of x cube with respect to x is equal to 3x squared. Let us consider another function y equal to sine x cube. Y equal to sine x cube, and we have to differentiate it with respect to x. Then we will write in this manner. Differentiation of y with respect to x is equal to differentiation of x, differentiation of sine x cube with respect to x. Now, in this case, we have to differentiate this function in two different ways. So first of all, we will differentiate sine function. Differentiation of sine function becomes cos, and this x cube function remain as it is, only we will differentiate sine here in first step. So differentiation of sine with respect to x become cos x cube, and now in the second step we will differentiate x cube with respect to x. Okay. So we have already solved that differentiation of x cube with respect to x is equal to 3x squared. Similarly, in this manner we will solve this part. So it becomes cos x cube multiplied by 3x squared. So it becomes 3x squared cos x cube. So differentiation of sine x cube with respect to x becomes 3x squared cos x cube. There is an important and interesting rule, that is chain rule, to differentiate a given function. Let us see. Here, if x is a function of t, at square, and y is the function of t, bt cube, and here asked differentiation of y with respect to x, that means we have to differentiate y with respect to x. Then what we should do? First, we have to differentiate x with respect to t and differentiate y with respect to t, because both are the function of t's. So we have to differentiate separately. After that, we have to divide differentiation of second function with respect to first function. So it's to first function. So we will solve it separately. So dy differentiation of y with respect to t gives us differentiation of bt cube with respect to t, where b is a constant value, so b differentiation of t cube. Second term will be 0 because differentiation of any constant number is equal to 0. So it's bt cube, and it becomes b. We will use here first rule, the differentiation of x to u to the power n is equal to n u to the power n minus 1 du by dt, like that. So it becomes 3 2 squared. And again, differentiation of x with respect to t, it's become differentiation of a t squared. So it becomes a differentiation of t squared, and here also second term will be 0. When we differentiate a constant number, it gives us 0. So differentiation of x with respect to t becomes a twice t. Now we will find out what is dy by dx. So dy by dx is equal to dy by dt and dx by dt. So dy by dt is what? 3bt squared, which we have obtained, and dx by dt is twice a t. So t and d get cancelled. So dy by dx is equal to 3b by a. So it is dy by dx is equal to thrice b by twice a t. So in this way we have to solve this type of problem.